Hello everyone, welcome to a new ICP5 from KDM. On today's ICP, we just finished implementing the both tasks of the ICP. For the first task, we created the five containing text data that perform the following task, which is the top 10 TF-IDF words of the above input, top 10 of words limitation on both and Ngram-based input. And for the second part, we wrote simply the higher consonant similarity doing the top 10 identified words for trying without NLP, with limitation, and with anagrams. And for that, moving along to the code. So what we did here, the start of the code simply like initiates the Spark efficiency and creates the data frame named a AP escape Spark, patches through the 5.6 files, the five text files, and then next in the rows are tokenized topic frequency of 10 features, and measure then scaled of inverse documents frequency, and finally pass to the end table. And then for the second task, the second mission or second task is a similar above task, similar of the above task. We just simply, but instead of scoring individual words, we will instead score phrases of words as they occurred in the text. This means we are taking an enneagram. An enneagram. Sorry, the first problem was of this lesson uses Spark to read five pieces of this. Sorry, my bad. Into a database from the net text abstracts summarized from uh, um, five academic journals obtained from ABS host using the search terms physics and conscientiousness since the start of the code, simply initiates the Spark and then named UpSysD, and then after that, next the rows tokenize the topic frequency 10, and then after that, the second task is similarity, but instead of scoring individual words, we just will score the phrases of words. That means we are taking an enneagram approach and assuming that the words important is somewhat determined by their neighboring words. And the only significant change from the above is that now we are combining words into groups of length, and we decided to use bundle size of 5 words as well, and 5 words per gram, and see how the results turn out. We also increase the number of extended to 10. It's just to see the results. Um, um, and now, so as you can see, we increase it to 10. And now, moving along to the second main task of the lesson, now we will attempt to vectorize our words in anagram groups. We'll search anagrams length to 2. In order to initiate, we will adjustant consistency of the words have with the one another. Here we are again grouping words onto anagrams, and a size of 3, then passing the anagrams themselves into the factorized results is a rich model that takes a further look at the context of each word. Excuse me. Then rendering its extract features into a measurable and comparable features. Finally, um, we mess around the factor representations of the words of this task, and we convert our word scores to vectors whose dimensional coordinately equals the number of features extracted of each word. After reading the files tokenized, we will pass the tokenized words through word to the word Tufik and Tufik function and create model with our features. Now we will onboard the word say science. How we will retrieve a list of synonyms words contained within our group groups of Gurnal ABST. That's all. It's about our our task for this lesson. Thank you so much for watching. For more details, I have the wiki report along with the screenshots and more details about each commands or each code commands and describing what each code for. Thank you so much for watching.